Question number 4. We're given a diagram and we're told that O is the centre of the circle, so that's here. We're told that AC is the diameter, so from here to here. B is a point on the circumference, that's this point here. And we are told that angle BAC, so that's BAC, this angle here, is 41 degrees. We're then asked to calculate the size of angle BOC, and that's this angle in here. In order to find the one we've marked in red, BOC, we'll have to find a few other angles first. So we'll take a slightly closer look. Since we know that this line is the diameter, then we should know that these two lines, the ones that come from each edge of the diameter to a point on the circumference of the circle, will always meet at a right angle. Now that we know that fact, if we now consider this triangle here, this big triangle, we should remember that the three angles in a triangle add up to 180. Now we know this one's 41 and this one is a right angle, which is 90. So those two added together will give us 131, which means that the third angle here will make the angles in the triangle add to 180. So 180 take away 131 gives us the angle here in the corner, which will be 49 degrees. Now that gives us another piece of information, but it doesn't yet give us the angle that we're looking for, the one marked in red. So what we have to look at now is this triangle here. Now the three angles in this triangle will also have to add to 180 degrees. What we need to spot, however, first of all, is that this line here and this line here are in fact the same length. Now the reason that we know that is because we know that this is the centre of the circle. Now any line from the centre of the circle out to touch the circumference is known as the radius. So this line here is the radius. That means that this line here is also the radius, which means that these two lines are in fact the same length. What that means is that this triangle is an isosceles triangle, and the properties of an isosceles triangle tells us that it not only has two equal sides, but it also has two equal angles. So that means that this angle in here is also 49 degrees. What that tells us now is that the three angles that we have in here, the two blue ones and the red one, will add to 180 degrees. The two blue ones, 49 and 49, add together to give us 98. So subtracting 98 from 180 will give us the angle in the centre, the one we're looking for, which is 82 degrees. That's the angle we're looking for, and that's the end of the question.